All right, so this is a 2009 Form B, question 5. And it says a bottle filling machine is set to dispense 12.1 fluid ounces into juice bottles. To ensure that the machine is filling accurately, every hour a worker randomly selects 4 bottles filled by the machine during the past hour and measures the contents. If there's convincing evidence that the standard deviation is greater than 0.05 ounces, the machine is shut down for recalibration. So basically, if the standard deviation varies, the standard deviation has too much variance, they recalibrate the machine. It can be assumed that the amount of juice that is dispensed in the bottles is normally distributed. That's important because that means we can not worry about that condition. During 1 hour, the mean number of fluid ounces of 4 randomly selected bottles was 12.05. Well, remember, this is my X bar, and this is what it's supposed to be. So that's my population mean. And it had a standard deviation of 0.085. Well, this is a sample standard deviation. Perform a test of significance to determine whether the mean amount of juice dispensed is different from 12.1 fluid ounces. Assume the conditions for inferences are met. That's nice of them. So I need to know whether this 12.05, this X bar, is substantially different than the 12.1. And this is and I'll need to use my sample standard deviation. So this is essentially a one sample t-test. So my claim is at 12.1. And then they want to know, is it different? So that doesn't give me a direction. So greater than and not equal to 12.1. Let mu equal true population mean amount of juice dispensed. I plug in, cross that out. And so when I go to run the test, I go to stat test, t-test. Oh, and I should have said, I forgot to label that. This is a one sample. We only have one mean, and it's a t-test because we're using the standard deviation of the sample. We're going to highlight the word stats because we're not working with data. We're working with summary statistics. So the mean is 12.1, or assumed to be. The X bar was the sample, and we ended up with a 12.05. We had a standard deviation of 0.085, and our sample size is pretty small at 4. So when I do that, I get a pretty large p-value. So that means, and by the way, there should be a 2 times here, 2 times that probability. That's greater than 0.05, so I'm going to fail to reject the null. So the p-value is 0.3245, which is greater than 0.05. We failed to reject the null. There's not enough evidence to suggest that the juice dispenser is dispensing an amount of juice that is different than 12.1 ounces. Okay. So we failed to reject. We don't have to worry about that. But the one thing that they mentioned earlier is that if this thing has a standard deviation greater than 0.05, they shut it down to recalibrate, and they got a sample standard deviation of 0.085. So it sounds like we may need to recalibrate this because this didn't match up. And that's leading us to, that's leading us to where we're supposed to be going. So to determine whether the sample of 4 bottles provides convincing evidence that the standard deviation of the amount of juice is greater than 0.05, a simulation was performed in the study. 300 samples, each of size 4, were randomly generated from a normal population with a mean of 12.1 and a standard deviation of 0.05. The sample standard deviation was computed for each of the 300 samples. The dot plot display shows the values of the sample standard deviations. Well, what we are caring about is whether or not we're over 0.085, which is about here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times that happened out of our sample size of 300. So use the evidence of the simulation to explain why you think the sample provides or does not provide evidence that the standard deviation is greater than 0.05. Well, we know we got 0.085. The question is that enough evidence? So they told us it's 0.085. It produced only 12 samples out of 300. All right, so 12 out of 300 is 0.04. Well, that's essentially my p-value. And if I had an alpha of 0.05, this is less than 0.05. So consequently, if I said that my null was the standard deviation is 0.05, or my alternative was my standard deviation does not equal 0.05, looks like to me this happened 4 times or greater than 0.04, greater than 0.05. It's like, oh, our p-value is 0.04. We got enough evidence at an alpha level of 0.05, because we would reject with this, because this is to suggest that the machine standard deviation is greater than 0.05 and needs to be recalibrated. So basically, all we did was say they had a sample 300. These are our 300 groups of 4, and these are the standard deviations they came up with. Some really small ones, this is where we're shooting for, is this 0.05. But we have a few really big ones. Well, how many big ones did we have when we did this by random chance alone? We had 12. Well, 12 out of 300, that gave us a very small p-value. And with that small of a p-value, we needed to reject the null so that we could recalibrate.